Hi everyone, my name is Daniel Bruce, and it's a privilege to be here today. Thank you all for coming out to hear me talk about a topic that I'm very passionate about, and that is the topic of automating visual inspections. Um, my role is partner and chief product officer at Levatas. Levatas is an AI solutions firm that's based in South Florida, and our clients include enterprises like Dow Chemical, BMW, NextEra Energy. We do build full stack AI solutions all the way from pilot through to production. But a key focus area for us is helping organizations like these navigate and automate industrial inspections. And that's in particular what I'm going to be talking to you about today. So first, just a quick agenda for what we're going to be covering today. First of all, I'm just going to talk a little bit about the computer vision space in general. And why companies are looking at using computer vision to automate their inspection process today. The next thing is I'll talk through some common business applications and some recent customer projects that we've been working on, just so you get a feel for what some of these solutions look like in the real world. And then finally, I'll end my talk just with some tips for how you can get started if you're considering an automated inspection program for your enterprise. I'll just talk through some common tips that we've found helpful with organizations that we work with. So first of all, let's talk through the computer vision space and why this is applicable to automated inspections. So computer vision is really a critical part of the automated inspection process for many different use cases. And in particular, it's really a part of unlocking true scale with automated inspections. So if you think about it, automated inspections typically involve using some type of smart capture device like a robot or a drone to go out and capture massive amounts of visual information. If all that you're doing is capturing that information and then having a human review that manually, it's much less powerful. If you're able to use computer vision to automate the process of not just capturing that information, but actually analyzing that information, that's really where you unlock a tremendous amount of value from the inspection automation process. So I'm going to talk through just three important sort of categories of use cases for how organizations are using computer vision in their inspection program. The first common use case is what we call batch processing. In this use case, typically you have drones or robots that are going out and capturing a large amount of data at scale. They're storing all of that information into a central data source. This could be cloud-based, it could be on-prem. And then after the fact, after that data has been captured and stored, this could be hours after the fact or potentially days or months after the fact. You have computer vision algorithms that are running over top of that data, looking for anomalies or objects of interest in those images, and then presenting that information back either via alerts or dashboards to business stakeholders so that we can inform better decisions. A second use case for computer vision, specifically in automated inspections, is doing route planning and optimization. So the idea here would be to run a first pass of for example, a drone capture or a robot mission, use computer vision to analyze that route after the fact, and then allow a human operator to, based on the objects or the things that were identified throughout the route, to actually do new planning or optimization of that route after the fact. And then the third use case, and this is kind of the most mature and the most sophisticated use case, is real-time mission optimization. And this could take the form of basically running a computer vision or AI model on the edge, on the device that's doing the capture, identifying objects of interest, for example, a worker in a hazardous environment that may not be wearing appropriate safety gear, or something like identifying a component that appears to be faulty. And with real-time flight optimization, what we can do is actually feed back that information to the drone or the robot in real time, have the drone modify its behavior, for example, by flying closer or zooming into the image of the object of interest so that we can actually get a closer look and understand what's really going on. So those are three Three very common use cases and three ways that we see organizations using computer vision in their inspection programs. The next thing that I'm going to talk about here are some common recent customer use cases so that you can get a feel for what these vision inspection solutions look like in the real world. The first use case was for one of the world's leading electric utilities. And what we did for them was we used computer vision to analyze footage captured from overhead drones. So they have thousands and thousands of miles of electrical infrastructure and equipment that needed to be inspected. They flew drones over top of the infrastructure, captured images overhead of each one of their poles. And then our computer vision algorithms were able to analyze that footage, post-process it, and then identify the components that were present in each one of those images, and identify things like where there might be line damage present or where a lightning arrestor might be faulty or in a pre-faulty state, and notify the appropriate human to take preventative measures. And in their case, this replaced a process that was very manual, where they had people going out and walking these power lines, identifying damage manually, or waiting for something to go wrong and then react and go out and try to figure out which component had failed that was causing the issue. So this type of proactive inspection is much more cost effective and also allows them to identify this damage proactively rather than reactively. A second use case, and this use case actually is coming up more and more for us in situations where we're using robots like the Spot robot to do automated inspections. In this use case, what we're doing is running a real-time computer vision model on board Spot. And the goal is to identify moving objects, potentially hazardous vehicles, in an industrial setting. So imagine having Spot walking around in a manufacturing plant, doing inspections of gauges or looking for leaks, those types of use cases. One of the biggest dangers for or obstacles for that type of process is that these environments are very busy environments. You have people moving all over the place, you have forklifts and all sorts of different vehicles that are moving through these lanes, sharing space with Spot. So Spot is smart enough to avoid bumping into an object actively, but out of the box, Spot doesn't know how to avoid a hazardous situation like stepping in front of a moving forklift and potentially getting run over. And so in this use case, we're actually running real-time vision models on board Spot so that Spot's able to look around his surroundings, identify where there may be, for example, a forklift in a lane, and make a decision on the fly to wait for that hazard to pass before stepping out into that lane. This really enables a much broader use of this type of technology in a congested environment like your typical manufacturing plant. Another common use case for us is gauge detection. And this is typically paired with either something like a Spot or a tracked robot, or potentially a fixed camera. In this use case, we have a number of customers that we're working with right now who we have built this for. And in their cases, what is commonly the case is they will have thousands or even tens of thousands of gauges that are in these plants that were built many decades ago. These analog gauges are very expensive, even prohibitively expensive to replace. In some cases, it literally costs hundreds or thousands of dollars per linear foot just to run power in these plants because of all of the logistics that need to be accounted for. And so the way that these plants are managing these analog gauges today is they literally have human experts who are walking rounds, looking at these gauges manually, writing down readings, coming back and inputting that into a computer system, and using an automated solution like Spot or a physical camera, plus a computer vision model that's able to read and understand these gauge readings. We're able to automate that entire process and escalate just the anomalous readings to a human. These readings can also be stored in systems like PI or SCADA, so that it can be blended with other data that's used to make smart decisions for the plant. Another common use case that we run into is illustrated by this use case. This was for one of the world's leading energy companies. And in this use case, what we're doing is running multiple computer vision models on Spot in real time, and actually having Spot adapt and adjust his mission on the fly based on real-time computer vision readings that are taken. So for example, in this case, we had a gauge reading model and a man-down safety detection model running on Spot at the same time. And Spot is programmed to respond to the readings, or if there's a man down detected along the mission, to actually modify his route and notify the appropriate human to take the appropriate mitigation measures. So hopefully that gives you kind of a good feel for what some of these use cases look like in the wild for real customers. The reality is, even though this is a very, very exciting space, I do want to acknowledge that automating inspections can be a challenging undertaking. And a lot of why this is the case is just because in all of the cases that I just talked about here, what they all have in common is they involve stitching together a lot of different components. So you have to think about where your data is living and and how you're doing and where you're doing the processing. You also have to think about the data capture component. Are you using satellites or drones or robots or fixed cameras or iPhones? There's a lot of different hardware components that have to be considered in the capture process as well. Then you have to think about, once you've captured that data, how do you actually integrate and pull this data from those appropriate sources and get it to integrate into the appropriate enterprise systems on your side, whether this is ticket management or your SCADA system or whatever that use case may look like for you. Then you have to consider the actual AI and intelligence part of this that does the processing of these images and identifies the objects or the anomalies of interest to you. Along with those AI models, you have to consider the life cycle of these models and how you manage that. How do you take data from real world inspections, use that data to pipe back into your models and make those models smarter going forward? How do you keep those models fresh as new types of, for example, as new types of gauges are released, new type of hardware or new components are being inspected during the process? You have to consider that whole life cycle of models. And that's a very complicated and important challenge to think through. And then you got to think through, how does this system actually collaborate with the humans that it's meant to interface with? And this typically takes the form of, how do we escalate ambiguous readings or things that we're uncertain about to an appropriate subject matter expert to validate, make sure that what we're reading actually makes sense. And then how do you push this information out to the right business folks so that we can make smarter and more informed decisions based on this? So the point is, there's a lot of these sort of disparate components that have to be stitched together to make a solution like this work. So I wish I could tell you that the whole story here is just around one of these components. If you could just get the right robot in place, you'd be golden. Or if you just had the right computer vision model, this is going to automate the whole process for you. The reality is those are critical components. Those are critical ingredients to the solution, but you have to put all of these pieces together to really see the value from this solution. And that is complicated. But fortunately, there are companies like Levatas that really specialize in doing that. And increasingly, we're seeing organizations see a lot of success from being able to put all of these pieces together. So with the last few minutes here, I just wanted to take a few minutes to talk through a couple of tips that we found especially useful for our customers, and pass those along in case you're considering this type of automated inspection program for your enterprise. The first tip is you really want to choose your use case carefully and strategically. You do want to think about data availability. So choose a use case where you have some degree of data available upfront that you can use for training. Now, a common question we get is, does this need to be hundreds of thousands of images or videos just to get started? Unfortunately, the answer is no. These algorithms use an underlying technology called transfer learning, which allows them to extrapolate a lot of intelligence from relatively small data compared to other types of AI algorithms. And so typically what we recommend is you want to have a use case where you have something on the order of a couple hundred images or maybe up to a couple thousand images available, or that you can go readily capture to bootstrap the algorithm. But you need to consider a use case where you have at least that amount of data available upfront. You also want to consider a use case where you have broad management and organizational buy-in. Don't pick something that's just on the fringe of your organization. You want to pick something where there's broader support so that you can easily parlay a small win into a slightly bigger win and not have to fight the internal politics along the way to sort of let that project play out within your organization. And then thirdly, when we talk about choosing the right use case, it's important to choose a problem where a partial solution to the problem is valuable. And what I mean by that is, if you think about a typical inspection process, you may have thousands of plants. Choose a problem where if you could automate the inspections at a small subset of those plants, that would be valuable. Or if you've got a 30-point inspection process that's being done manually today, choose if you can focus on maybe 2 or 3 or 5 of those inspection points. If it's valuable to automate those and perform those inspections on a more frequent basis, those types of problems tend to be really good, as opposed to problems where you have to automate 100% of what's being done today before the organization sees the first lift on the bottom line. And this is just practically about setting up an incremental success so that you can solve a small piece of the problem, expand, solve a little bit more of the problem, expand to more plants, and kind of build successes incrementally like that. So again, choose the use case that you focus on, especially for your first couple use cases. Choose those very carefully. A second big recommendation that we make is to set realistic expectations up front. So this is an incredibly exciting space. There's a lot of opportunity, but you want to avoid both the hype and the fear extremes when thinking about what's possible. So first of all, there is a lot of fear mongering in this space around robots coming to take over the world, take away our jobs. The reality is when you get in and look at what's possible with these solutions, that type of concern in these settings is way off in the future. These types of solutions require still a good bit of customization. They still require a lot of human involvement to be effective. And so there's very little fear of these machines coming in and taking over the world. On the other hand, they have real limitations. And so you want to be careful to understand up front that 100% automation usually is not possible. Don't expect perfection, because if you go in expecting 100% automation, you expect a perfect solution up front, you're going to be disappointed. If you set realistic expectations up front and you understand that this is going to be an iterative journey, you're really setting yourself up for success. Speaking of success, the next recommendation that we make to our customers is to carefully define what those success criteria look like. If you're working with a data scientist, the default for a data scientist, and this is for good reasons, but data scientists are trained to think about success in terms of very technical metrics like precision and recall or F1 score. Those metrics, while they're relevant for a business, they typically do not capture what really matters to your organization. And so we recommend thinking of your success criteria in terms of what really matters to you. So that might be, for example, if you've got 1,000 plants and your goal is to automate the inspection process, think in terms of how many of those 1,000 plants have we been able to automate? Or another common way of setting that up is if you spend today 1,000 man hours a day doing these inspections, set your success criteria around reducing the number of man hours that are required so that you can see 3 months into this, we've been able to reduce that by 10%. 6 months in, we've been able to reduce that by 30%. And you can measure what that real value looks like to the bottom line of the organization. Based on these success criteria, then we recommend that you set up measurable success milestones against those criteria so that you can measure not just intangibly, but you can very quantifiably measure the success of this inspection program over time. That helps you measure whether what you're doing is actually working and also build momentum. So if you're seeing progress in that direction, you can justify the additional investment that's going to be required to go from 10% to 30% to 50% and so on. The next recommendation we make, and this ties to the iterative approach overall that we suggest that our clients take, you don't want to wait until the solution is, quote, perfect before you release it. And the reason for that is perfection is very, very difficult, if not impossible, for a lot of these use cases. If you have defined your incremental success metrics well, you want to ship your solution when it's able to achieve that first success milestone. That's where you're adding value to the bottom line of the business. And very importantly, what that does is it gets value for the organization sooner. It builds trust within the organization. And critically, it gets feedback from real world scenarios. And that feedback is absolutely critical for being able to refine and improve the model's performance over time. Okay, and then another recommendation we make related to that is you want to take advantage of every opportunity to use human expertise and human feedback in real time to improve model performance. Every time that an AI model identifies something that looks strange or new or ambiguous to it, you want to take the human feedback for those ambiguous cases. Those are absolutely invaluable data points for continuing to refine and improve model performance. This is true of every data point, whether it's positive, where the human agrees, or negative feedback, where the human is contradicting or disagreeing with the model. It is especially true, though, of these negative instances where a subject matter expert and the AI disagree. It's not always the case, believe it or not. It's not always the case that the human is right. In a lot of these inspection scenarios, the humans are quite error prone themselves because of a number of different factors. But in any case, getting that type of feedback helps you very quickly identify the potential places where you've got soft spots in the performance of your model. And you can use that data to continue to refine and improve that. Lastly, related to this, you want to make sure that the feedback loop, the loop that takes that human feedback and uses it to improve the model performance, you want to make that as automated and streamlined as possible. Because if that process is completely automated or nearly automated, you're able to feed that intelligence back into the model very quickly. If it takes months and months, or in some cases even years, for that feedback to make it back into the model, you're just wasting all of that time and all of that valuable improvement that could be accomplished much faster. And so as much as possible, you want to push towards an automated or nearly automated feedback loop. All right, so I hope in this short talk, it's hard to cover sort of the whole world of opportunity in this space, but I hope that this gives you a good feel for what we're seeing in the real world around this, some real world applications. And if you're considering doing this yourself, I hope some of those tips also give you some ideas for how you could go ahead and get started. If you do have thoughts, if you're considering getting into this yourself, we would love to hear from you. We're very passionate about helping organizations navigate this space themselves. And so please feel free to reach out, drop a comment in the chat here, or feel free to reach out to us directly. We would love to talk to you. So thanks again. Appreciate you coming out and appreciate your time.